Here's integrated 3. It's problem 3-83, and this appeared on your test, and there's 4 parts, so I'm going to try to go a little bit quick through it. But the directions were: solve the following systems algebraically. What does the solution reveal about the graph of the equations in the system? So we have to solve these systems algebraically. So this is a line and that's another line, and they may cross somewhere. And so you guys know how to either use equal values, substitution, or elimination. Those are pretty much your options. This one to me looks good for elimination. So what I'm going to do is I'm going to subtract the bottom equation from the top equation. The reason I'm allowed to do that is I can subtract the same amount from each side of the equation, and since the 2 is equal to the x minus y, I'm allowed to subtract here. So x minus x is nothing. 2y minus negative y is actually going to give me 3y, because if you go 2 minus a negative, that gives you 3y, I believe. And then 17 minus 2 is 15. And then divide out my 3. And that gave me y is equal to 5. And so now that I know that, let's use a different color. Now that I know that y is 5, I can plug it in somewhere. So I'll just use this original equation. I know that x minus y equals 2, but y is 5, so I plugged it in. So then I can just add 5 to both sides. And then I get x is 7. And so that means that these are 2 lines and they cross at 7, 5. That's the meaning of it. Because I think it asked, what does it mean? Or it said, what does each solution reveal about the graph? So it reveals that the lines intersect at this point right here. All right, moving on. So again, we have another set of equations. They're both linear, and I see that I could use elimination on it. If this was a -4 and that was a +4, they would I'd be able to eliminate the x's. So a lot of times I just rewrite them, like I just write an arrow, and this one I'm not going to multiply it by anything. I'm just going to leave it as 4x plus 5y equals 11. This one, I'm going to multiply the whole thing by -2. And when I multiply, I'm going to multiply out to each of the terms. So -2 times 2x gives me my -4x that I want. -2 times 6 gives me -12y, and then -2 times 16 would give me -32, I believe. And then these are going to cancel out. 5 minus 12, I think that gives me -7. And then I think this is going to make 21, -21. And then divide out. And so y equals 3. And if y is 3, then I can plug that in somewhere and get x. I think I'll just plug it into this bottom equation. So 2x plus 6 times y equals 16. Well, 6 times 3 is 18. If I subtract 18 on both sides, and divide, I have x equals -1. So now I have -1 and 3, so I can say that these 2 lines intersect at -1, 3. That's the intersection. I'm just going to write intersection of the lines. Okay, there's more. So this one, I wrote over the top of it, but the original equation was 4x minus 3y equals negative 10. And then this one just has x equals 1/4 y minus 1. This one I don't really want to use elimination on it because this one's already solved for x and I can plug it in right there. So I'm going to rewrite the first equation as 4 times, well, x minus 3y equals negative 10. So I just rewrote this and I left a big blank spot for x because I know down here it says x equals this. I'm going to substitute this in. So this is 1/4 y minus 1. And then I'm just going to multiply out my 4. So 4 times 1/4 is 1, and 1 times y is y. 4 times negative 1 is negative 4, minus 3y equals negative 10. So the y and the negative 3y makes negative 2y minus 4 equals negative 10, plus 4 on both sides. Negative 2y equals negative 6. So if I divide, then y equals 3. So I found y, and then I want to find x, and I see right here would be a nice place to plug. Oh, sorry. Right here would be a nice place to plug in my y. So I'm going to say x equals 1/4 times y. I'm going to write it as 3/1 minus 1. Okay, so then x equals whatever 1/4 times 3 is, that would be 3/4 minus 1. And 3/4 minus 1, that makes negative 1/4. So that's x. So now I know that the lines intersect at negative 1/4, comma 3. So far, our lines, we keep having these two lines and they keep intersecting. Here's the last one. Oh boy. So this one, I don't have that much room, but I'm gonna like add 2x on both sides. So if I did that, I'd have 4x plus y equals 5. I guess that's what I did. And so on this one, I think I'll minus 2x. Oh my goodness. And I guess I'll minus 3y also. Okay, so that makes all the right-hand side equals 0. And over here I've got 3x minus 2x is x, and 2y minus 3y is negative y. So this whole thing can be written as x minus y. So it's getting a little messy, but this first blue equation, I rewrote it as 4x plus y equals 5. And the second equation, I just kind of cleaned it up and wrote it as x minus y equals 0. And now I'm going to use elimination because I see that I can add, if I add these equations together, my y's will disappear. So I've got 4x plus x, let's do it in pen. 4x plus x is 5x. Y minus y is 0. And 5 plus 0 is 5, and divide both sides. And x equals 1. So now I've done all this work, and made a giant mess. Got x equals 1. So I can plug the x equals 1 in and find out what y is. So where should I do it? I think I could plug it in right here where I have x minus y equals 0. So if x is 1, I'd have 1 minus y equals 0. So I think y's got to be 1. And if I wanted to solve it, I could like subtract 1 on both sides and divide by negative 1. and I have y equals 1. Okay, so 1 comma 1. So actually all of these lines, this was on your test, all of these lines intersect at a point, and those are all the points where all the lines intersect. So that was a lot of algebra. That's called systems, solving a system of equations. That's what you did algebraically on this problem.